Lab 2. This lab is designed to reinforce the material you have just covered of calculating area under a curve. When you open Lab 2, you'll notice in the bottom there are different tabs. I'd like to make sure that you are clicked on the right rectangle and trapezoid graphs. Very important, otherwise you might see something else pop up. So make sure you're on the correct tab to begin with. Now, I want you to take a look at this zone over here. This is the actual area, and it is referring to this function f of x equals x squared between 0 and 6. So here's my graph of the parabola x squared from 0 to 6, and we're looking at the area underneath the graph. The exact area is 72. What this Excel spreadsheet allows you to do is change the number of rectangles. I could have 2 rectangles, or I could enter possibly 4 rectangles. And when you enter the rectangles, the number of rectangles, it changes the area from those rectangles. Now, what I would like on this graph, on your lab, is for you to increase this number of rectangles, and we're going to have the right rectangles here, and this area over here is trapezoid. And a trapezoid basically is like a rectangle, except for instead of being connected on one side of the graph, it's connected on both sides for each trapezoid. Now, what I'd like you to do on the lab is to increase the number of rectangles 2 at a time and make a table showing me the area of the right rectangle estimate for 2 rectangles, 4 rectangles, 6 rectangles, 8 rectangles, and I'd like you to go all the way up through 40 rectangles. And again, what I want to see, and I'd like this, you can do it in Excel or you can do it in Word. Either way is perfectly fine. But somewhere, making a table with the number of rectangles, and this chart, you can't do it in this chart because it's cell-protected, but you can do it in Microsoft Word, and you don't need to make a table, but when n equals 2, the area of, let's go back to my graph, of this for 2 rectangles is 135. Is that correct? That seems wrong. Yeah. So when n equals 2, my right rectangle area is 135. And you'll continue to increase that and document that from 2 through 40, raising it by 2. When you're done with that, I'd like you to talk about how the area of the rectangles compares to the shaded region below the graph from the function itself. So what happens as you increase the number of rectangles? That's the first thing. Short couple sentences should be sufficient here. The next thing, what I would like you to do is show the formula for 4 rectangles of how you can get this height and width of each rectangle. For 4 rectangles, then I'd like you to show it for 6 rectangles. For each and every rectangle, I'd like to see the height and width. You can round to the 100th place for it, but I'd like to see the formula, and then I'd like to see it for 8 rectangles. Now, last and but not least, I'd like you to try to show what a generalized formula might look like if you didn't know the number of rectangles. So 4 rectangles, 6 rectangles, 8 rectangles, then n rectangles where I actually see the formula with the values for the areas of the rectangles giving me the height times the width. Then, what I would like you to talk about, last but not least, is how this applies to the integrand of the function. You may turn this in on a Word document or in Excel, whichever is more convenient for you to produce.